Consider the region bounded by the curves y equals x squared and y equals 4 in the first quadrant. Find the volume of the solid formed when the region is revolved around the x-axis using square cross sections. Picture time. Picture time. All right, so we're looking at y equals x squared. Okay, and we're looking at y equals 4. I'm going to be very bad at this. If I'm going to try to draw square cross sections, it's going to look something like that. Okay, squares going to look something like that, and then they get smaller, and then they get smaller, and stuff like that. Okay, now these are squares, and what we're looking at is whatever the height is between these two curves is also going to be the length. So if we're looking at 4 and x squared, the length of each side is going to be 4 minus whatever x squared is at the moment. So that's the thing that I need to look at first, is that the side length is going to be 4 minus x squared. Now, I care about the areas of these squares because what I'm going to do is integrate the area, and by integrating the area, we get volume. So if the side of a square is 4 minus x squared, then the area of a squared is the side squared. So the area, okay, a of x, I guess we can call it, is going to be 4 minus x squared squared. And so by integrating the area, okay, we get ourselves volume. All right, now what I need to do is, it's not good enough for me to just integrate. I don't have any limits yet. I don't have limits of integration or anything like that. So I know you start at 0, but what are you going to be? Okay, what are you going to be? So we set these guys equal to each other. X squared equals 4. We don't lose sleep because I know that all I have to do is square root both sides. Okay, don't forget your plus or minus, and you get plus or minus 2. And then you remember that, oh yeah, we're only focusing on the first quadrant, so my limit is going to be 2. So you are going to be from 0 to 2. So let's set this equation up. Let's set this integral up. The integral from 0 to 2 of my area is 4 minus x squared squared dx. All right. Now, before we do anything, let's FOIL that out. Okay, that's a perfect square trinomial. So you're going to be 16 minus 8x squared plus x to the 4th dx. Now I can integrate. Okay, 16's integral is going to be 16x. The integral of negative 8x squared is negative 8/3 x cubed. And plus x to the 4th is going to be plus 1/5 x to the 5th. My limits are 0 to 2. All right, so we set up our integral again. Well, not set up our integral, we set up our math problem. So we get 16 times 2 minus 8/3 times 2 cubed plus 1/5 times 2 to the 5th minus. If I plug in 0 to all three of you, you become nothing. So let's not overcomplicate things, shall we? Let's not. We're at this stage, we're this far into calculus, we don't need to overcomplicate things. You become 32. 2 to the 3rd power is 8. 8 times 8 is 64, so minus 64 over 3. 2 to the 5th is 32, so 32 over 5 is 32 over 5. Ugh. So I have 3 fractions in here. Common denominator is going to be 15. So multiplying 32 by 15 is going to get you 480 over 15. Multiplying u by 5 is going to be 320 over 15. And multiplying u by 3 is 96 over 15. $480 minus 320, 160, no, 140, 140 plus 90, no, it is 160. 160 plus 96 is 256. All over 15 is going to be u. Oh, boy, is that a gross problem. Didn't like that at all. The bounded region shown represents the base of a solid. Find the volume of the solid based on the given cross-section. Set up the integrals and evaluate. All right, so we're doing a cross-section of a square, and we're doing this perpendicular to the x-axis. So this is what we need to do, okay? Here are my boundaries. 0, I don't know. We've got y equals 2. We've got the cube root of x. All right, so by doing cross-sections of squares, we are creating a bunch of squares, right, all throughout this whole thing. And what we're going to do is we care about finding the area of these squares. Oh, that's such a bad picture. We're finding the area of these squares so that we can integrate that to find our volume. All right, now what I have to focus on is what are the side lengths of each squares? Well, if this top equation is 2 and the bottom equation is root x, then each side length is going to be 2 minus root x. And so if each side length is 2 minus root x, then to find the area of a square, we square the sides. So the area is going to be, a of x we'll call it, is going to be 2 minus root x squared. Okay, so what I need to do now is I need to find out what that limit is right there. The way that I can find out what that limit is right there is I could take my two equations down here and set them equal to each other. The square root of x equals 2. In order to get root x all by itself, I'm going to square it. X equals 4, and these guys intersect at 4. So the integral that I'm going to set up is going to be the integral from 0 right here to 4 of 2 minus the square root of x squared dx. Now, before I even consider integrating, I want to FOIL that out. I want to use a perfect square trinomial and clean that up. So that's going to look like 4 minus 4 root x plus x. Oh, this is going to be terrible. This is going to be terrible. This is going to be terrible. This is going to be so bad. Let's rewrite this out. Between 0 and 4. 4 minus 4x to the 1/2 plus x dx, and wish me luck. All right, so breathe in, breathe out. We have the integral of 4, which is 4x. Okay. We have the integral of this guy, which is going to be 4 over 3/2 x to the 3/2 plus x squared, 1/2 x squared, with limits at 0 and 4. So let's clean this up a little bit more. 4x, this is going to be, if I flip this and multiply, this is going to be 8 over 3, so 8/3, so minus 8/3 x to the 3/2 plus 1/2 x squared. My limits are, squared's in the wrong spot. My limits are going to still be 0 and 4. Now the nice thing about this guy is, I guess, if there's a positive anywhere, here's a light at the end of the tunnel. Okay, when I plug stuff in, I'm going to have 4 times 4, no big deal. Okay, no big deal. Minus 8/3 times 4 to the 3/2, that's very unpleasant, plus 1/2 4 squared. If I were to do the minus and then do the same thing and plug in 0, it's all going to become 0. So we'll just say minus 0 and save some time. Okay, u becomes 16 minus 8/3. If I square 4, I get 16. And the cube root of 16 is going to be 2 root 2. No, it's not. 2 cube root of 2. Yeah, there's nothing I can do about that. Oh, no, I take it back. I'm cubing 4, which is 64. And then the square root of 64 is 8, so that's not that bad. I apologize. Plus 1/2 of 4 squared is going to be 1/2 of 8. Or 16, which is 8. So u becomes 16 minus 64 over 3 plus 8, which is going to be 24 plus 64 over 3 multiply the top and the bottom by 3, giving you 72 thirds plus 64 thirds, and that's going to end up being 156 thirds. Gross. So definitely not a pretty problem at all. Not by any stretch of the imagination, but we did it. All right, this one's going to be very unpleasant. The x-axis in the graph of y equals the square root of 1 minus x squared. Each cross-section perpendicular to the x-axis is a rectangle whose height is 10 times the width. So basically what we're doing here is we're trying to find the area between these two curves. So you're looking at a rectangle, right? Looks like that. Looks awful. Let me scoot you over to make that maybe a better representation of a rectangle. Look at that. Look at that. Okay, and so what we're kind of looking at is, all right, what we're told is the width of this rectangle is going to be, it's a rectangle. So you have a rectangle, the width is going to be the square root of 1 minus x squared. The height of it is going to be 10 times that, 1 minus x squared, right, times 10. Now, in order to find an area, you multiply the length and the width. So the area formula is going to be 10 times the square root of 1 minus x squared times the square root of 1 minus x squared. Now, this makes life very convenient because that times itself makes the square roots go away. So you're left with 1 minus x squared. So the area formula ends up being 10 times 1 minus 10 x squared. So what I'm going to do is I'm going to integrate this guy. I'm going to integrate 10 minus 10x squared dx. Issue number one is I don't know my limits yet. But what I do know is this guy is set equal to the x-axis. So I'm going to do 0 equals the square root of 1 minus x squared. Let's square both sides. Pretty easy stuff. That's just going to make the square root go away. So 0 equals 1 minus x squared. Let's add x squared to both sides. So x squared equals 1. Okay, square root everything, positive or negative, and x equals plus or minus 1. So you are going to be negative 1, you are going to be positive 1, and I just now realized that it gave us that already. It already told us that. So whatever. So I'm going to integrate from negative 1 to 1, 10 minus 10x squared dx. Okay, the integral of 10 is 10x. The integral of negative 10x squared is negative 10 thirds x cubed. And my limits are negative 1 and 1. Okay, so I'm expecting a lot of repeats going on here. I'm expecting a lot of repeats. We got 10 times 1 minus 10 thirds times 1 cubed, close it, minus 10 times negative 1 minus 10 thirds times negative 1 cubed, close it. Okay, 10 minus 1 cubed is 1, 10 thirds is 10 thirds, so minus 10 thirds, minus negative 10 plus, and the reason why it's going to be plus is the cube of negative 1 is still negative 1, so negative 10 thirds times negative 1 is still positive 10 thirds. Okay. If I pretend that 10 is 30 thirds, then I get 20 thirds minus, and if I pretend that this is 30 thirds, then I get negative 30 or 20 thirds. And again, these are going to be the same because they're just the same. They're the same area underneath. So that's going to give me 40 thirds. So kind of a strange problem, but I liked it.